All right. We'll take it from the top. These questions are quite straightforward. Let's see um, what is expected in each one. So basically, we have to come up with the equation and then solve them. So that's the interpretation of the word problem and then the solution. So the first one says Lily has three less than four times the amount of t-shirts as Bree. And it goes on to say if Bree has 33 t-shirts, how many does Lily have? Three less than four times the amount um, that as amount of t-shirts as Bree. Okay, so well, this one I don't know if this particular questions look like um the figures were already given three less than four times. Maybe it's more like you just representing them. You might not really have more of an unknown. But let me see. So what we're going to do is we will use the unknown and then we'll now substitute whatever needs to be substituted. So the first one, um, if we use L to represent what Lily has, right?
Yes, sir.
So three less than four times the amount of t-shirts that B has. So if I use B to represent what B has, right? That's going to be three less than four times is going to be 4B minus 3. Okay. So that's how I would interpret three less than four times. Now, they now told us that B has 33 t-shirts. So that means we can safely substitute um, 33 anywhere we have B for B. And that would be 4 times 33 um, minus 3. And multiplication has higher precedence. So we'll have 4 times 3 is 12. 12 plus 1 is 13. So that's 2 carry 1. So we'll have 132. 132 minus 3. And that would be
129.
129. Yes, 129. So, okay. So, yes, that would be how many t-shirts that Lily has. So if we were to solve it that way, that's how it would be. Um, okay. So it's quite clear, even from the look of the question, that Lily has more than Bree. I mean, imagine four times and then you just subtract three from it. It's definitely still going to be more. Okay, so let's look at the second one. Second one says four times a number. So four times a number is equivalent to eight more than two times that number. What is the number? Okay, so this one is like the typical question, right? What is the number? So Of course, we'll start by representing the number using a particular letter. I would suggest we use n. So again, interpret the question based on how the question was framed. 4 times a number, 4 times n, is equivalent to is just as good as equals to 8 more than. So 8, now notice that they didn't say 8 times more than, they just said 8 more than. So in that case, it's just going to be addition. 8 plus, sorry, my addition looks like a t. So let me write it well. It's plus I meant to write. So 8 more than 2 times the number is 8 more than 2 times the number. So the question now is, what is the number? Of course, and my 8 is okay. No, let's just leave the 8. At least it looks like 8. Even though it wants to look like B a little. Okay, so what will we do in this case? What do you think we'll do?
Mm-hmm. Are we going to bring it over and then
Bring what over?
mm, 8?
8. Okay, we should bring 8 over
Yeah, to the
to
other
where?
side. Mm.
Uh, do you want to take 8 that way, or do you?
Let's just, what about 4n?
Okay, um, you want 2n to move over to meet 4n, right?
Yeah.
I think that would be better. So that would be 4n minus 2n. Okay. And that will be equals to 8. Since 8 didn't move, it will be, what do you call it? The same. It would stay the same. And the 2n sign changed. So 4n minus 2n is 2n. And that would leave us with 2n equals 8. Uh, we'll now divide both sides by 2 to have it that n equals 4. Because that's the only way you get rid of that 2 in front of n. So 2 in itself is 1, and 2 in 8, sorry, 2 in 8 is 4. So we have that n equals 4. Okay, all right. Um, okay, so let's go to the next one. Um, okay, you understand it, right?
Yes, sir.
Okay. Uh, let's see. This next one says number 3. Pedro is 8 years older than twice the age of his cousin. Pedro. So if we use P to represent Pedro's age, and we remember that is in mathematics can be uh, likened to equals to. So Pedro is, that's what we've just written now, 8 years older. Same thing as that 8 more than. 8 years older is going to be 8 plus whatever comes after the 8 years older. So that's going to be 8 years older than twice the age of his cousin. They did not tell us the name of his cousin, so let's just say 2C. We use C to represent the cousin's age. So twice the age of his cousin. They now told us that if Pedro is 30 years old or 30, okay, so how old is his cousin? In other words, they're telling us that P, remember, is means equals to. So P equals 30. That's what they're trying to say, or that's what they're saying, rather. So anywhere we see P, we can put what?
30.
30, yes. So we'll go ahead and just place 30 there and solve for C. Okay, so if you notice something, some of these equations started with us having two unknowns, but as we properly interpreted it, the two unknowns gave way to just one, and that is one requirement for any system of equations. The number, I don't know if I said it when we were talking about simultaneous equations, the number of equations must be equal to the number of unknowns. Okay, so if you have two unknowns, guess what? You must have two equations to be able to solve for the two unknowns. Any system that you have the number of equations being less than the number of unknowns, trust me, you can't solve it. It's an insolvable situation. You can ask any mathematician. It's something that you can solve. You still end up with one, at least one unknown if that kind of scenario comes up. Okay, so let's go ahead and solve this. So now we can collect like terms, right?
Yes, sir.
So what's going to happen here?
Mm, should we bring the 8 to 30?
Yes, we'll bring the 8 to join the 30. And because there's no sign in front of it, we know this sign is definitely an imaginary plus sign. So the 8 has cross sides. It must become a minus compulsorily, leaving us with 2c on the right-hand side of the equality sign. So 30 minus 8 is 22. So we have that 22 equals 2c, and so we already know what c is, because 2 times 11 is 22. So we can just divide both sides by 2, and we'll come up with 11 for C. Sorry, let me not go and write something else there. 22 divided by 2 is 11. All right. So we have that C equals 11. Okay. So let's move on. All right. Okay. So this one has a bit of words in it. Let's see what it says. A car, a rental service charges a rental fee of $125 plus $30 per hour. Okay, so let's take note of those figures. They're throwing a lot of figures in our faces, but we just take note of them so that we don't miss out any detail. So a rental fee. So this one is like a flat fee, right? Of $125. They now said plus $30 per hour. So now per hour means it now depends on how many hours the service um, was rendered for. To rent a car, and well, of course, renting a car can take different hours depending on what the person wants to use the car for. They now said if Craig's total bill is $305, question, how many hours did he have the rental car? Okay, okay. Ha, I think they meant to say for how many hours did he have the rental car? In other words, how many hours did he use the rental car? Okay, so what do you think we'll do first here? What do you think we'll do first?
Mm,
Remember, there's a flat fee before we now start charging per hour. So what do you think we'll do first?
so 125
Mm-hmm. Okay, 125
plus 30
uh, 125 plus 30 Okay, plus 30 what?
Mm,
Do you want to choose the letter? You are free. You can choose any letter you want to represent the number of hours he had the car for.
mm, just H.
H, okay, we'll use H. I also thought of using H too. All right, so
Mm, equals
equals
305.
exactly 305, correct. That's the best thing. That's the best way to go about it. Okay, so if we solve this now, that this should basically give us the answer to our question. Perfect. We used all the figures. Now, I was teaching um well, some people earlier today. So I told them something. Sometimes it's not all the numbers in a question that you make use of. But in this scenario, yes, you needed to use all of them. So yeah, so we're good to go. All right, so I guess we can collect like terms, right?
Yes, sir.
125 we go over this side to meet um 305. So that will leave us with 30h on the left hand side of the equality sign, and that would give us what on the right hand side? 305 minus 125. Okay.
Mm,
Okay. All right. So 305 minus, sorry, I was about to write plus now. 125. So what would that give us?
that's 180.
180. Okay. Okay.
Okay.
Yeah. Because 30 minus 12 is 18. That's true. Okay. 180. Let's write it very carefully. 180. Okay. So what are we going to do to both sides now?
Divide by side by 30.
Exactly. Divide both sides by 30. And my h is, so this guy is just, okay, I can see it now. Divide both sides. um, okay. Okay, so okay. So if I divide both sides by 30, this is what will happen. 30 will cancel out 30, and that would leave me with 1h on that side. And 30 would take out 180 to leave us with what?
6.
6. Yes, exactly. Because 6 times 3 is 18. So we have that, therefore h equals 6 hours. Okay. Okay. All right. So that's how long he had the car. Okay, so let me see if I can save this annotation because it's I wanted to just do it like this because I think it's better when you are looking at the question, instead of minimizing and all that. Maybe I would do, okay, let's do image. Question nice. Where did it save it to? Oh, nice. Interesting. I didn't even know. Okay, I think this is by meeting assets. Okay, no problem. I'll come back for it later. You see no one close. Oh. Okay, I think it's because this one is open. Okay. So if I minimize it now to close. Okay. All right. So let me go back to the this thing. So you understand, right?
Yes, sir.
Okay. So let me clear the drawings and go to the next bit. Okay. All right. Annotation. Okay. Okay, this one says number five. Two times a number, right? Increased by 10 is 24. Find the number. Two times a number. So we know anytime we see times, multiplication is involved. Two times a number increased by, again, increased by is alluding to addition. Then is, of course, is our number equals to 24. And the question is for us to find the number. Okay, so what are we going to do here?
Bring the 10 over to the 24.
Exactly. So I'm going to have 2n equals 24 minus 10, which
40.
is 14, yes. Um, yeah, and that will leave us with 2n equals 14. And we'll divide both sides by 2 to give us
7.
7. Yeah, so we'll have that therefore uh, n is equal to 7. Okay, so I think we can go to the next one now that we know that n is 7. The next question says Kyla spent 120 minutes, right, reading this week, a whole 2 hours altogether. If this was 10 more than two times the amount of time she spent reading last week, okay, so that means she spent more time this week than last week. How many minutes did she read last week? Okay, so this kind of one now, we're going to do an equation in terms of last week's number of minutes, right?
Yes, sir.
Because that's the one we want to find. And yeah, technically, we already know how many minutes she did this week. So let's use a letter to represent that. How many minutes she did last week. So maybe we can use M. Okay. So if we use M, what equation will come out from this? Can you tell me?
Mm. Like if we use like I don't understand.
Okay, we said we're using M to represent the number of minutes that she spent reading last week. So what is the equation that will come out to help us solve for that M?
Mm. I don't know
Just
the
look at it
like,
carefully. It says if this was more than two times 10, this was 10 more than two times the amount of time she spent reading last week.
is it quadrat?
No, it's still linear. All these equations are linear.
Okay.
Hmm.
So are you asking that how we are going to write it?
Yes, how will the equation look? Just like you did
Oh,
for this
okay,
one,
okay. I thought
or
you
that we
were
did. No,
asking
the one that
for
you did for that rental car. Yes. Okay.
okay.
Hmm.
So if it's so 120,
Okay. You want us to start from 120? Okay,
yeah.
120. Yes.
This was more
What next?
so 10 more than times
Hmm.
plus
Should I put a plus after the 120?
yes.
Hmm.
Wait, if this was more, is it times 10?
Okay. So Notice what comes after the first sentence. It says, if this was, see the was, right? Did you notice that was is a form, what they call that thing? Past past tense form of is.
Minus 10.
So since no, so hold on. Since was is just like is, but it's just like in past tense, they say something was. You understand? It's like past tense of is, right? Do you agree on that?
Yes.
Okay. If that's the case, then anywhere you see was, you're also free to replace it with equals to.
Okay.
Yes. So now I've helped you. We have taken care of the was. So now go ahead. You can finish it up.
10 plus
10 plus, good, because they said 10 more than. So 10 plus,
2t.
mm-hmm, 2t. You want us to use t?
Yeah.
Okay, all right. So I'll do my best to write t to make it look different from plus. Okay. So if this happens, what do we? So this what we can solve, right? Two times the amount she spent reading last week. Okay, that's fine. All right, cool. So, what do we do next?
Bring over the 10 to 120.
Aha, bring over the 10 to meet 120. So that's going to be 120 minus 10 equals 2t. And that should leave us with 110 uh, equals 2t. 110 equals 2t. Okay, so we'll divide both sides by 2 to find t, because that's what we're looking for. We're looking for t. And that would be
Yes.
2 in 110 is what?
55.
55. Okay, all right. So therefore, t equals, sorry, t equals 55. Okay, so that's 55 minutes. Yeah, 55 minutes. Okay, so let's head on to the next one, which is number 7. Um, Number 7 says what? The sum of three consecutive even numbers. When you start saying consecutive. Have I explained the meaning of that term before?
No. Is it the same?
Not really.
Okay.
So, consecutive means that they come after one another in a
Okay.
particular order. Okay, so for instance, if I asked you for consecutive natural numbers, you know that natural number starts from one, isn't it?
Yes, sir.
So what's the consecutive number after one? Is two, right?
Yeah.
One, two, followed by three. So if they say, okay, give examples of three consecutive natural numbers, any three, you can put, because you just know that natural numbers increase by one to get the next one. So you can say 34, 35, 36. You are safe. Okay.
Mm.
But if you do something like this, 34, 35, 37, what have you done? You've skipped 36, isn't it?
Yes, sir.
So technically you only have two consecutive natural numbers, and the third one is not consecutive. Why? Because it has skipped the one that should have been the third one. So consecutive just means coming after the other, and it depends on what you are dealing with. So let me now give you another example. So this one is even numbers. Now we know that 35, 37 is odd numbers, right? It's a pair of odd numbers. 35, 37. After 37 will come what?
39.
39. So if we're not talking about consecutive odd numbers, then 35, 37, and 39 would meet the conditions for consecutive odd numbers, right?
Yes, sir.
Okay, so you got the drill. So now let's see what this one is talking about. Sum of three consecutive even numbers is 18. They now asked us, what are the three numbers? Okay, interesting. Now, somebody might be thinking, let's play a guess game. But I bet you that when you can't really get away with guessing when they want to see your working, right? So it's better to just solve it. Okay. So usually, if you want to do this kind of thing, right? Let me see the best way you can go about it. They said sum of three consecutive even numbers. So since they're even numbers, one way somebody can do it is to say if the first one is n, then the next one will be what? N plus 2. Am I right?
Yes, sir.
And the next one will be n plus 2 plus 2, which is as good as what? N plus 4. Do you agree with that?
Yes.
Okay. So now we have gotten the three consecutive even numbers, but we have not solved them yet. We haven't gotten their actual values. But they told us that their sum is what? 18. At least that's the information they gave us. So we will now attempt to add three of them. So we can now say 18, excuse me, 18 equals n plus n uh, plus 2. Okay, so I've just added the first two consecutive even numbers. I'm about to add the third one plus n plus 4. Okay, all this is equal to what? 18. So your best bet is to collect like terms, right?
Yes, sir.
I'm sure you can see n, n, n. So what are we going to do to uh, uh, those things? N, n, n. What should we, when we're adding them? N plus n is what?
3N.
3n. Thank you. So 3n plus what? The still on the right hand side. I have 2 and I have plus 4. So 2 plus 4 is 6, right?
Yes, sir.
So 3n plus 6 equals 18. And remember, we're looking for we'll first find n. Then when we find n, we can find the other even numbers. So we'll move 6 over, right, to meet 18.
Yes.
So that will be 18 minus 6 equals 3n. So you can see how the thing is solving itself. The number will soon emerge. So that will now give me 18 minus 6 is 12. 12 equals 3n. All right. So we'll divide both sides by 3 to give us 12 over 3, which is 4. Okay. All right. So we have found one of the even numbers at least. So now that we found that one, of course, that means we can find the remaining two, right? So the even numbers will be 4, 6, and what? 8, isn't it?
Yes, sir.
And if you check it, you see that when you add three of them, you actually get 18, right?
Yes, sir.
Mhm. Okay, so let's take a look at number 8. Number 8 says, you give a third of your weekly allowance to a charity. Hmm, that's interesting. Okay, is the person that generous? Probably. Most people won't even give any of their weekly allowance to any charity. Okay, then you spend $8 at the mall. Um, okay. If you have $2 left to spend, how much is your weekly allowance? Okay. So, can you tell me how we go about this? Let me even ask you, have you ever given any of your allowance to charity before?
No.
You probably think that it's not even enough for you, right?
Yes, sir.
Mm-hmm. Okay. So this person was pretty generous to give a third. So that means if they were, if we are just looking at it critically, they divided their weekly allowance into three. One part of that three, they gave it to a charity. Then the remaining two-thirds, they out of that two-thirds, they spent $8 at the mall and had $2 left to spend after they've spent the $8. Okay, so the question now is how much was their weekly allowance? Okay, so if we're going to form an equation, right, for this, it's safe for us to say that the weekly allowance should be the total of if whatever it is that we want to use as the equation that shows this person's spending pattern. Okay, so the person gave a third of their weekly allowance to a charity. So that's 1/3 of something. Do you agree with me?
Yes, sir.
Okay. So let's start with that. Maybe we should call the weekly allowance W. So now this my pen that usually disappears. I have to move against something that has black before I'll see it again. So now I've seen it. Let me move it down now. Okay. So 1/3 of W, the weekly allowance, 1/3 of the weekly allowance, plus they said $8 was spent at a mall, and my plus is looking like it's looking like a cross. Okay, yeah, okay. Plus $8 at the mall. The $8 is not any relationship to the weekly allowance, so you just write 8, and then $2 was left. So that's plus 2, isn't it?
Yes, sir.
Okay. This question is even simple now. And when you add all this, it should give you back W, isn't it? The weekly allowance. Am I right?
Yes, sir.
All right. So what do you think we're gonna do here? This 8 and 2, they are free to go together, right?
Yes, sir.
Mm-hmm. So that the equation now will be left with. So I'm free to write W as W/3. Yeah, because instead of writing that one/3 W, I can write it as W/3 plus what? 10 equals W. Okay. So question now is, what do we do next?
Mm-hmm. Multiply all by 3.
By 3. Good. Good. When you multiply all by 3, we'll be left with W plus 30 equals 3W, because nothing will be spared when you multiply by 3. Everything will be affected on the equation. So now don't forget, I'm doing a line here to demarcate it. We're managing our space. So we can now collect like terms, right? So which one should move?
W.
W. Nice choice. So I have that, okay, there we go. I have that 30, because if W moves, we have that 30 is equal to 3W minus W, which is going to leave us with what? 2W on the right hand side equals 30 on the left hand side. So what are we going to do to both sides now?
Divide by 2.
Exactly. We divide by 2, and 2 takes out 2, and 2 takes out 30 to leave us with
15.
15. Yes. So that's it. Our weekly allowance has emerged as $15. Yep, $15. Okay, so that's it. And if you just want to do a check, I don't advise that you do a check for all your questions, especially if you're in a test or an exam, because you don't have time. But then, just to boost your confidence when you are not doing an exam, a third of 15, that's 1/3 times 15 is 5. So if you take out $5 from 15, you have 10. And actually, that's what happened. Spend 8 out of 10, you have 2. So everything lines up. Okay. So you understood that one, right?
Yes, sir.
Okay. So I'm going to save this too. So that's what I'll send to you when I'm sending stuff. PNG. Okay. All right. So um I think I don't think is there any other question on this? Let me close this. Yeah. Okay. Hmm. Okay. I'm looking to see if there might be something else that might look interesting. Hmm. Okay. Okay. Let's see how this guy looks. This one look long. Okay. Let me see this one. Okay. Um. Uh, this guy looks really, 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 really tiny. And it's not clear. It is not clear. Not something I want to take a risk on. Let me see this one. This one looks too simple, Abby.
Mm, let me zoom in.
Okay. Can you see it now?
Yes, sir.
Mm-hmm. It looks pretty simple. Let's take a look at this one. Uh-oh. Sorry. Ah, not clear. Not clear. So, okay, let's try this single. Okay, let's see what this one looks like. Oh, sorry. Okay. Um, hmm. Okay, let's see what this one looks like. It says read the following word problems. First, write the problem as an equation with a variable. After completing your equation, solve it. Okay, let's take on this one. See how it goes. All right. So this first one says Trent scored 4 goals at the soccer game. His team, the Battling Badgers, scored 12 points altogether, but still lost by 3 points to the Wailing Wombats. The question is, how many points did the rest of the Battling Badgers score? Okay. So I hope my interpretation of this question would not depend on my understanding of goals versus points in a soccer game. 4 goals. So Trent scored 4 goals at the soccer game. His team scored 12 points altogether, but still lost by 3 points. I don't know. I have a feeling that there's some understanding I need to have about goals and points, and that would be required for that question. So I'm going to skip it because I'm not a soccer fan like that. Or do you know the relationship between goals and points?
No.
No, okay. I guess maybe your dad will know because he will probably be good with soccer and all that, but I'm not. Okay, let's move on. Mr. Bonga or Bongo, I don't know what that is. Bongo and Doodles are therapy dogs. Mr. Bongo uh, hold on, saw half as many patients as Doodles. Okay, plus 3 more. If Mr. Bongo saw 15 patients, how many did Doodles see? Okay, so this one is still testing your understanding of, certain terms. Bongo saw half as many patients as Doodles. And then the next sentence now says Bongo saw 15 patients. So half as many as Doodles. So now notice it said plus 3 more. So if Bongo saw 15 patients, how many did Doodles see? So what do you think we'll do in this case? What do you think we'll
So
do in this case? Yeah?
half
Yes. Okay,
plus
Bongo saw 15, right?
yeah.
So half of what?
Mm,
Half of what doodles, right? So I'll say, let's just say half D, okay, plus three more, according to the question, right? Plus
Yes,
three
sir.
more. Uh-huh. And all this is equal to what? What Bongo saw, which is what? 15,
15.
according to the question. So the question now is, how many did Dudu see? So our job is to find D. So we'll take 3 to this side, right?
Yes, sir.
To meet 15. And we'll have that half D or D over 2, instead of, that one now looks like something else. D over 2. Let's write the D very well. Okay, over 2 equals 15 minus 3. Okay, all right. And 15 minus 3 is 12. So that means that D over 2 is equal to 12. So what are we going to do to both sides to find D?
Uh, we are going to multiply 2.
Exactly. We're going to multiply both sides by 2 because that's the only way that 2 in the denominator will disappear on the left-hand side. So that's what I'm going to do now. Times 2. So 2 will cancel itself and times 2 on the right-hand side. So that D will be equal to 30. Ah, so my D is looking like something else. Okay. Yep. So D is equal to,
24.
sorry, 24. Yes, not 30. 24. Okay. So yeah. Mhm. Yes. Okay. Okay, let's go on. This next one says Greg and Parker are baking cookies for the school's bake sale. I think that is bake sale. Okay, so Greg bakes 3 times as many cookies as Parker, but eats half of them. Wow. Hmm. Greg must have been hungry. So what does it say next? Greg now has 48 cookies for the sale. So the question now is, how many cookies did Parker bake? This is an interesting question. So take note that these 48 cookies that Greg had was after he has eaten half of the number that he baked. Did you get that part? Did you get that part of the story?
Yes, sir.
Okay. So let's now try and help Parker to know how many he baked. So let's look at it again. They're baking cookies, blah blah blah. Greg bakes 3 times as many cookies as Parker. Okay, but eats half of them. Let me see. I'm interested to know how you will represent this. So how would you represent this?
3 times half.
Mm, you want to do 3 times half?
Uh, wait.
So look at it though. 3 times as many cookies as Parker. So there's a 3 times, but do you think it's on the half?
So 3 times 48.
Uh-huh. Now, 48 is what Greg has. That's why I was asking you that time. Did you see that part of the story? 48 is what Greg has after, this stuff. So it's not even Parker's own. Okay, so three times as many cookies as Parker. Okay, so the truth is that we don't know how many Parker baked, right? So
Yeah.
let's just put Parker's own as P. Okay, so let's just say three times P. Okay, now they now give us, there's a but there. It says, but then he eats half of them. So half of what? Half of 3p. So half of 3p is going to be 3p over 2. Do you agree with that?
Yes, sir.
Okay. So let's get that down first. He eats half of them. So they are saying after all this arrangement, Greg has how many? 48. Does it make sense now?
Yes, sir.
So the question now is, how many cookies did Parker bake? So um I think you know what to do, right? The same thing. I don't know where you did that. Well, I think it was in one of those previous ones that we did. So what do we do to this particular equation?
Mm, do we multiply them by 2 or
Yes, exactly. We're going to multiply by 2 so that we take care of that fraction. So 2 times 3p will give me
6b?
6p minus, and I multiply 3p over 2 by 2, it will leave me with 3p. Okay. And all this will be equal to 2 times 48, which is 96. So you can, I'm sure you can see what we'll do next. The like terms are already together. So 6p minus 3p is 3p, right?
Yes, sir.
So that's 3p equals 96. All right. So we'll divide both sides by 3 to find what p is. That's what Parker baked. Okay. Wanted to make the something go across it. Okay, so when we divide 96 by 3, what do we get?
32.
32. So Parker baked 32. 32 cakes. So yeah, 3, 2. Okay, so I think we had a bit of challenge with interpretation, but I guess you understand it better now, right?
Yes, sir.
Okay, so let me save it. Okay, I'll send you all the things that I saved. I hope they show with the question in the background. I really hope they do. All right, so um let me see if my how long my battery can take. Okay, it's not going to show because I am okay. Okay, 53. Hmm. All right, so let's see if I can manage one more uh, this thing. One more pair of questions. Zoom out. Hmm. Okay, let's see what this guy looks like. What is this? Ah, bye bye. What is all this one? Okay, all right. Let me see if. Okay, so I don't know if this is clear enough for you to see.
Mm, it's not that
Can you
bad.
see the,
I'll just
you can
edit
see it?
it to make it sharp.
Okay, to make it sharp. Okay, you have an app that you can use to do that.
Yes.
Okay, all right. So maybe let me even look at the question. So Edward has four coins. One coin is a 5 penny and the other three are identical. The total amount he has in his pocket is 65 pennies. What are the other coins? Okay, so this one is quite interesting. But the problem now is that number five and number six have been blocked by that number five and number six have been blocked. Hmm. Okay, all right, no problem. Let's see. Um, let's um, let's see if you can walk around one, two, and three. Probably I'll probably look for another one that is complete to give you for some practice that you can do on your own. Okay, so the first one says Edward, right, has four coins. One coin is a 5 penny. Okay, so at least um we know that one of them is a 5 penny coin. Let me quickly do this. Okay, can you still see my screen?
Yes, sir.
Okay, nice. So just looking a bit strange, sha. Okay, all right. So Edward has four coins. Four coins. Let me move that there. So there are four coins altogether. And all we need to do now is to represent the four coins and then know what exactly we really have. Okay. So they said one of the coins is 5 pennies. So we're already sure of that 5p. Okay. They now said that the remaining three are identical, right? So do you agree with me that it's safe for us to say something like this? 3x, since we don't know what the remaining three are, but we know that they're identical. Do you agree
Yes,
with
sir.
that?
Yes, sir.
Okay. But they told us that his total was how many? Let's look at what they said his total was. They said the total amount he had in his pocket or he has in his pocket is 65 pennies. So you know what we'll do? I'll delete that P so that it doesn't confuse us as if there's another unknown somewhere. Sure you understand what I'm saying?
Yes, sir.
So 65. I know that it's 65 pennies. So that's the unit. No need to represent it. So of course we're going to collect like terms. 3x will be left on the left hand side, and uh 5 will go to meet 65. So that it becomes what? 65 minus 5, which is equal to what? 60. Okay. Um, that's 3x. Okay, so we're dividing both sides by 3 to give us 20. So let me see. What was the question, sir? Was it asking us how many
Many.
the remaining, Abi?
Yes, sir.
Okay, so I think that solves it. What are the other coins? So the remaining are simply 20 pennies. Okay. Okay, so let's move on to writing the units. Okay. The next one says Mrs. Jones does what? Had 4 lollipops left. Only had 4 lollipops left. She ordered another 5 boxes. Sorry, let me move this thing. She ordered another 5 boxes, so she would have plenty to give out at Halloween. If she has 64 lollipops, including the 4 she had left. Really? Okay. So this is after she ordered. So she now had 64, which means the 5 boxes that she ordered gave rise to 60. Do you agree with that part?
Okay, yes, sir.
Okay. If you don't agree, you can read it again so that you get, because me, as I'm reading it, even the first time, I usually tell people to read questions twice, especially word problems. Read the questions twice to get the gist of the question. But if you can be interpreting it as you are going, it's perfectly okay, because that means you'll be faster in getting to the solution. So, including the 4 she had left, the question is, how many are in each box? How many are in each box? So let's analyze that second to the last phrase. If she now has 64 lollipops, including the 4 she had left. So that means the the other, the 5 boxes must have given rise to what? 60 lollipops.
Yes, sir.
So as it is now, all I need to do is to say 5x, because I don't know how many are in each box. 5x equals 60. Do you get? So that's
Yes, sir.
that's what's that's the distance. That's what it will be equal to. 5x equals 60. And if I do that, um 5x equals 60. So that means x will be equal to what? Divide both sides by 5, right?
Well,
And that will be 12. Yes. Okay. Uh-huh. All right. So that's it. So there's 12 in each box. Okay. X equals 12. Okay. All right. So let's move on to the last one now. It says at the cheesy, um, hmm, hmm, I can't really say that. But anyways, factory, something factory. It says it costs £8 per kilogram for cheddar with a minimum order of 5 kilograms. Okay, so let's get, because it looks like this one already has some figures that are dependent on each other. £8 per kilogram for cheddar with a minimum order. That means the lowest they can order from that place is what? 5 kilograms, right?
Yes.
Remember, it's £8 per kilogram. So that means 8 times 5 is 40 already, right? £40. That's the lowest one can spend on that minimum order of what? 5 kilograms. The question is this: if Mr. Bree spent £96, question is, how many kilograms did he buy? There are even two questions. Second question, how many more kilograms did he buy than the minimum required? See, two questions in one. So question is, how many kilograms did he buy? Then they now said, how many more kilograms did he buy than the minimum required? So how will we solve this particular one?
Mm,
How would you solve it if you were to solve it?
8 pound.
Remember, this told you how many pounds per kilogram? £8 per kilogram. So how would you solve it? And they now told you that he spent £96 altogether.
8 mm, kilogram equals to 96
Eight.
kilogram. No,
No,
eight
is it?
pounds. 8 pounds.
Uh,
Mm, equals 96.
I think maybe you left out something. What would you? You need to do something to the eight. It would the eight stand alone.
8 kilogram. Or
Okay,
eight,
so
eight
maybe you
C.
are thinking of, yes. How do you want to represent the unknown? So if we can't use kilograms. Let's use another letter.
C. 8
Let's
C.
use a letter. 8C. So that C is the number of kilograms, which we don't know, right?
Yeah.
Okay. So 8C equals 96. Let me call them by their numbers. So this is number one, number two, and number three. Okay. So um number three. So 8C equals 96, right?
Yes.
Okay. 8C equals 96. Okay. So we're looking for C. That's the first question. So we're going to divide both sides by what?
8.
By 8, correct. So I'll have 8 in itself on this side is gone. And 8 in 96 is what?
Oh,
12. Okay. So that means The man bought, because the first question said what? The first question said, how many kilograms did he buy? Right? How many kilograms did he buy? Then I said, how many, so the how many kilograms did he buy is 12 kilograms. So that's 12. The second question is this. Um, how many more, right? How many more kilograms did he buy than the minimum required? Remember, the minimum required is how many kilograms?
5 kilograms.
5 kilograms. So how many more means 12 minus 5? Do you agree?
Yes, sir.
So that's how many more. If you want to use M to represent it, the how many more will be equal to 12 minus 5. 12 minus 5. And 12 minus 5 is 7 kilograms. Okay. All right. Okay, so I was thinking that initially that there was a this thing. What's number four? Number four is okay. Okay, so this thing blocked number five and number six. Okay, let's quickly do number four. Number four says Margaret, Jacob, and Harris all swim for the Saint team, whatever is that, in one season. In one season, they won 18 medals between them. So that means the total was 18, right? That's my first deduction from this question. Total, when they say between them, that means that's their total. Okay. The next thing that I can see there is they told us that Margot won 6 medals, Jacob won 7. So that's 6 plus 7, 13. Question is, how many medals did Harris win? That one is simple now. It will be 5, isn't it?
Yes, sir.
So this one does not need any writing. It's um it's simple enough. 6 plus 7, 13. 13 plus 5 is what will give you 18. Okay, so I think it's safe for us to go for the day. But I'll find one question like that and send to you. Okay, this one looks interesting. Okay. This one is simple interest. Hey, hey. No, this one is not. Okay. All right. So, yeah. Do you have any questions?
No, sir.
Okay. All right. So, okay. I think we'll solve this one. Okay. So we'll see. Um, are you doing anything on Saturday?
No.
Okay. All right. Oopsie, oopsie. Okay. Okay, maybe I'll send you this one. Will they allow me to download it? Let me see. Oh, interesting. Yes, they did. And let's see how clear it is. Okay. Yeah, it looks pretty clear. Okay. So I'll send you that for you to work on your own. Then I'll send you all the things that I saved from the annotation, including the one that's in paint. Okay. So I'm thinking maybe we can even, possibly, if you want us to continue, we can continue this on Saturday, just so that you get more used to different types of word problems and see how they can be interpreted. Yeah.
Okay, sir.
Yeah. Okay. So I will let me just bookmark this. Okay. All right. So enjoy the rest of your evening.
Thank you, sir.
All right. So I think the time on Sat, what time did we even meet that last time? 10 o'clock your time or 11 o'clock your time
The what?
that we met. Well, it was not last week, so maybe the week before last.
Oh, yeah, it was 10 o'clock my time.
10 o'clock. Okay. All right. So I think we can do that. Okay. So have a good night rest.
Thank you, sir.